So Trisha, you're the one holding the floor. How best can we do it? Where do we even start from?
Supposed to pick a question or?
I'm showing you, so you start with question 1.
I explain. I don't understand.
Yeah, you guide us on how steps to take, what to do. Like you are the one solving it, and then maybe I'll help you with writing.
I don't.
You don't what?
Okay, I can do it.
Okay, provided you follow, I'll be holding the floor. So here, we have to follow a little bit of board mass. You need to understand that board mass, but even if it's board mass, we need to understand that here we have this question solved in terms of indices in some ways. And the first part that we have to do is to understand that when any number raised to power 0 or any term that gives us a 1, so that gives us 3 squared plus 3 negative 1 then times 1 because of the negative power. That's the first thing. Second thing, when we follow the board mass, we multiply this, we still get 3 squared plus this. Nothing changes because we're multiplying this negative 3 with a 1, so it comes out the way it is. And when we get here, we go to the rule that talks about negative power. So when the power is negative, you will reciprocate it. So we'll have 3 squared plus the reciprocal of this, it means 1/3. And then from here, we move this way. We're going to have 3 squared. I'm just writing it again. Plus the reciprocal, which is just a 3. The power is a 1. You don't write it. So we understand that 3 squared gives us a 9 plus 1/3. So here we can make it over 1 as well, so that the common denominator being a 3, and then we divide 1 into 3, gives us a 3. 3 times 9, we'll have 27, plus 3 into 3, that's 1. 1 times 1 gives us a 1. And our final answer will be 27 times 1 gives us 28/3. So that's how we're getting done. Are we okay?
Yes. Yes.
Good. So that is how the answer is. We move on to the second question. This information cannot be saved, so we just have to erase it. Then we go to the next one. The next one is this question, which is saying simplify. So simplifying, we're trying to get the simpler form of that question. How do you do it? Whenever we have the number written outside the bracket, it means that number has to multiply everything inside. So this is multiplying an x. This also multiplies that. We subtract. This multiplies that, and this multiplies that. So 2 times x here, let me use a typing form. 2 times x gives us 2x plus 2 times 3y gives us 6y, gives us a 6y. Negative 3 times 4 gives us negative 12x. Negative 4 times 4, negative 3 times 4x. And then negative 3 times negative 2. It turns out to be positive, and that to be positive 6. So from here, the only thing that we have to do is to collect the like terms, and the like terms are this term as well as that. So we'll have 2x minus 12x plus 6y and plus 6. Let me write the beta 6 plus 6. So these two terms, we subtract two different signs, we get a sign from the bigger number, and we're going to have negative 10x. That's a simpler form, plus 6y and plus 6. And remember, these terms are unlike. The first one has got an x, the other one has a y, this one is constant, doesn't have any sign, therefore these terms cannot be simplified further. And that's how we end with the answer. Okay, we'll move on to question number 2. If you're not clear, please you raise your concern so that we address them here. Number 3 rather, we are told to factorize the question. There are three methods. There are three methods of factorization. The first one, I'll push this information by the corner. The first one is factorization by grouping, which is not the one we are using. Second one is by using product, sum, and factor. Then the third and the last one is by the use of the perfect squares. There are many methods, but these are the ones that are commonly used at our level. So looking at the one that we have here, the one that we're going to use is a perfect square. But when we are using a perfect squares, we make sure that in the middle of our factorization, we need to introduce the double brackets. Then this only works if the sign that we have here is negative, because we must look for two different signs, which when you multiply, they give you a negative, and these signs are one must be positive, the other one must be negative. But when you look at the question that we have, there's nothing here which is a perfect square. And therefore, this thing that we have, we need to make sure that we obtain the perfect form, the perfect square form of whatever numbers that we have. What do? We factorize this 3. So when you take out a 3, what remains inside is x squared, which is now a perfect form, minus 3 divided by 29 gives us 9. So this 9 is now also a perfect square, which if you so wish, you can write it as 3x squared. Now the form in which the x is written, we can also write it here as a 3 squared, so that we see that this now makes sense. So in our final answer, we pick our 3, which is already outside the bracket. We write it here. Then we open 2 brackets, one here, another one there. So here, I will just show you the simplest way. remove the powers. Remove the powers here, remove the powers. It's the simplest way I'm showing you. I'm not going to explain how this is done because you might have learned this, so I'm just interested in finding the overall answer. So, okay, let me change this. So we have x minus 3 here. When we remove the powers, we are going to have a repetition of whatever we have written inside the bracket, but except at this time, we are going to have a different sign here. We are going to have x plus 3. So this is the final answer for the factorization that we have here, which is 3 outside, x minus 3, and we have x plus 3. So that is the final answer. That's the method for the product sum and factor. We got the next one, question number 4, which says, find the gradient of a line passing through the points, those 2 points. It's just a gradient, nothing much, nothing less, just a gradient. And we understand that the gradient is the stiffness of a line, where I would say the gradient of a line, which is denoted by m, must be equal to the change in y from y2 up to y1 divided by x2 minus x1. So if we can take that this is 0.1, we can say that this is 0.1, then we say that this is 0.2, then that means we can say that this will be x1, this will be x1, and then comma y1, understanding very well that any point is denoted by the x value as well as the y value. The number that comes first represents the x value, the number that comes later represents the y value. So because this is 0.1, then this will be x2 comma y2. That's what we're going to have, y2. Meaning in our computation, where we have got x2, we know what to put, it's 0. Where we've got x1, we'll put that. Where we have y1, we'll put that. And where we've got y2, we'll put that. So the formula says y3, and the y3 is a 3. So we're going to say 3 minus our y1 is negative. Now there's already a minus, so this 1 comes with its own minus. So we have to put the brackets to separate the signs. Our x2 here is a 0, so we're going to put a 0 here, minus our x1 is negative 3, so we're going to have negative 3 here. Our x1 is this, which already has a negative. So when we have got 2 signs that are following each other separated by the bracket like that, we multiply them. Then we get the resulting sign. So negative times negative gives us a positive. So here we're going to have a positive 1 over. Same applies here. We're going to multiply so that we get a resulting sign. So we'll say 0 plus 3. And when we compute what's on top, we get to have a 4 over, we compute what's at the bottom, 3 plus 0 or 0 plus 3 gets us a 9. So therefore, this is the stiffness of a line, which is called the gradient. So this is the gradient. They just said find the gradient. They did not tell us to find the equation of a line, whatever. It's just a gradient. So we just end there. Then question number 5, which is the simplest of them all. Allow me to maybe reduce so that I can have 2 questions on the same side. Okay, yeah, maybe like this. Better. So we have the question says, shade A union B A A union B, which is inside the bracket. Now, A union B is what we are shading. But A union B, which we are shading, should not contain anything within C. That's what it means. A union B, we are shading everything in A. We are also shading everything in B. But regardless of how far we do the shading of both sets, nothing within set C should be handled. So what we are saying is that anything within this set C should not be talked about. But one thing we know for sure is that this is A and this is B. So the combination of that should be shaded. But when you look at this, region, it's with this region here. It's within the union of A as well as the union of B. But again, it is within C. And they have said that we need to take the complement of C, that within set C, nothing should be shaded. So meaning this part will be exempted because of the complement which is on C. So with all that said, we can do the shading. And how easily do we shade it? Allow me to maybe use a different system of shading. Okay, denied. I'm trying to get some bingo. So we are going to shade in that way. We are shading here. We are shading, but no, the form of shading which is done is by using lines. So we're just going to shade this part, which is A union B, all that part shaded, except for anything that is contained in C. So this is how our shading is supposed to be done. Now here I have seen a question where I've seen a situation where students start drawing circles of their own. No, they're saying in the space below. So don't write in the space below. So don't write on the Venn diagram. So don't write anything of your own. Don't draw anything of your own. Just do the shading on the question, on the diagram which is given. Question 6, though we have not done the vectors yet, but maybe I can solve it because we're getting to that. So points in vectors, I would say this. In vectors, there is no going straight. Vectors, we don't go straight. We pass through the origin. Let me show you what I mean. I'm going to have points. I'm going to have points. I'm going to have points. So look here. What is happening? I'm moving from point A. This is point B. Well, let me use actually okay, let me just explain. From A, B, then we are going to C. So we are moving from A going to B, then from B going to C, which is as good as just moving in from point A going direct to C. So it is at this point where we say that vector AB, the combination of A and B from A to B, when we add to B and C, it's the same as just moving from A going direct to C. But except that when you're showing vectors, it is always important to show the arrow that you're moving from point A to point B, from point B going to point C, which is the same as from B going direct, from A going direct to C. That's what it means. Now, with the addition question that we have, the basic principle here is this. These that are written as column vectors, when we see this written P as a 3, 4, meaning the number which is on top, first of all, we need to understand that this can also be written as a 3, P or as 3, 4. this can also be written like that, which means the first number is for X and the second number is for Y. So the principle here is this. When we say PQ, when we say PQ, okay, maybe before I even wrap that, let me use this. So let's say from A going to B, let's say this is B. I'm just showing you. And okay, let me say from A going to B, let's say this is A. And from B going to C, this is B. And from A going to C, this is C. So what does it mean? What does it mean? Meaning, we are running out of time. Meaning, for us to find, for us to add A plus B, A plus B, which is giving us a B, which is in the actual sense is a C. So the only thing that we do here is that PQ, moving from P going to Q is the same as Q minus P. How this comes about, you can only understand it if we understand the meaning of arrows. When you're going along the arrow, the sign is always positive. When you're going against the arrow, let's say the arrow is going this way, then you take the route going the other way around, the sign becomes positive. So they're saying that given that the column vector P, now remember how else this P can be written. So where there's P, we have this. And where there's Q, we have that. So find PQ, or what we are saying is that we are doing Q minus P. This is a subtraction of vectors, which will come and learn later. So what do we have on Q? What do we have on Q here? We have -1, 1. Then we subtract. What do we have? Oh, yes.
I have a question.
Yes, please.
You said when the arrow is going to the other way, it's a positive. Then when it's going the opposite, it's a negative. But there the sign, arrow is pointing to the direction of where it's supposed to be positive. So don't you think it's supposed to be Q plus P?
What I say?
I'm saying the arrow. The arrow on top of PQ.
The arrow on top of PQ. Yeah.
Yes. You said when it's pointing to that direction, it's a positive, right?
When you are going along the direction of the arrow. When you are going when you are going along the direction of the arrow, the numbers must be written in a positive way. The reason as to why I've put a minus here, it is because the P is in the opposite direction of the arrow. But this is a new topic that maybe we need to have a background. I was just trying to bring some highlights here. So our P, which is 3, and then remember the other way in which this vector can be written, which is 4. Now, what does it mean? These two numbers are subtracting, and these two numbers are subtracting, which means we are going to say -1 minus -3. This gives us -4, comma. We are saying 1 minus 4. This gives us -3. So this is the meaning of PQ. Actually, for you to understand the meaning of P, for you to understand the meaning of Q, and the meaning of numbers, this has to be explained well on a graph. Yeah, you have to, this is explained well on a graph that's when you can pick the best explanation. This was just the rough way I was doing. But always, whenever you just say PQ, it means do Q minus P. If it's QP, then what you need to know is that it is P minus Q. Always for such questions that are written in position vectors. But the meaning of a 4 here on X, the meaning of a 3 on X, and the meaning of a 4 on X, this will come and explain it later when you look at the actual vectors. Okay, work is being recorded, it will be sent. So we are now on matrices where we are given the matrix P and the matrix Q. And we are told that the first one, we just need to transpose what we have. So what we have here is a 4, -1, we have a 0, we have a 2 here, we have a 0, we have a 3. This is first row number 1. This is row number 2. So transposing it, row number 1 will be written as column number 1. So we will have 4, we'll have -1, we'll have a 0. Then the second column in this way will be written in a vertical way. So we'll have a 2, we have a 0, we have a 3. This is what it means to transpose. So this is P, which is transpose. So transpose of matrices, you change the rows be written as columns and then columns being written as rows. This is A. Then B here, where we are told to multiply our P here. P, we have a 4, we have a -1, we have a 0, we have a 2 here, we have a 0, and we have a 3. This is multiplying matrix Q, which is 1, 2, and 3. Again, here we need to understand the multiplication of matrices is done row by column. So we'll be multiplying this way with a vertical way. So the first one will be 4 times 1 gives us a 4. Now we are adding, and -1 times 2 gives us a -2, and the 0 and the 3 gives us a 0. So the first row is done. But there's only one column in the second vector, the second matrix. So we'll go by the same again using the second row. So we'll have 2 times 1 here, which gives us a 2. We add 2, the 0 here, and the 2 gives us a 0, plus a 3 here, and a 3 here. We'll get a 9. And therefore, 4 plus -2, like I said, different signs, you multiply. So here we're going to have a minus. So 4 minus 2 minus 0 is going to give us, a 2, and a 2 plus 0 plus 9, this gives us 11. So this is what we are going to get. This is what we are going to get. Okay, so we go to the next one in a single minute that is remaining, which is this one, question 8. The arithmetic progression. One thing we know about arithmetic progression is that when you subtract 2 consecutive terms, the answer you get is always the same throughout. And that's why it is called common difference. So here, if we are to, the first term is 4. So we say if you subtract the consecutive terms, T2 and T1, the answer must be the same as subtracting T3 minus T2. For AP, we subtract. So our T2 here is a 7 minus our T1 here is 1. We are saying the answer must be the same as T3, which is 13, minus T2, which is 7. So when you subtract these two, the answer will be 6, which is the same as 7 from 13 is also 6. That's why this is called the common difference. So now finding the 8th term, we are saying Tn is equal to A plus n minus 1, and